Alright, you're welcome to my channel once more. And in the previous video we were able to prove this proposition over here, and today we are going to try and prove these two propositions. So with the second one, we are saying measure or Lebesgue outer measure, okay, is translation invariant. So what does it mean? What is actually translation? Here we actually have the real line from negative infinity to positive infinity, right? And we are saying that translation is measure is translation invariant. So if I'm given any set, if I call this E, if I'm to translate this, E could be, let's say it's the interval AB, then what we are trying to say is that AB is actually given as X such that A is less than X less than B. So we are talking of all the X values within this. We are talking of all the values within this set. Okay, yeah, and that's given by this S such that S is always going to be greater than A and less than B. So if you are to translate this set by a factor, say Y, that's going to be E plus Y. Okay, then what we are saying is that this is going to be every X, the X's we have here, okay, plus the Y's, such that the X belongs to the E. Okay, and Y is also a real number as well. So you realize that when you are doing that for each element here, okay, when you add, say, the boundary of this set to the Y, it's going to shift this to another point. Okay, and you do so for all elements by the same scale factor. So in the end, you realize that this E is going to move from where it is to another point. Okay, so let's say after adding all the X's to the Y's, you're going to have the set moving or shifting to that side. You can easily see that when after shifting, the elements were still in like the same distances with respect to themselves. Okay, or let me explain it this way. You realize that the elements are only moved by just Y. So let's say an example was, say I had 1 to 5, the open set 1 to 5, and I wanted to translate it by 3. Okay, so let's pick an example. When I pick 1 plus 3 is going to be equal to 4. So it means the lower boundary of the next set is going to be from 4, and the upper boundary is going to be 5 plus 3, right? So that's going to be 8. Now let's look at the outer measure of 1 to 5. It's going to be 5 minus 1, which gives you 4, and 8 minus 4, which gives you the same 4. Are you getting it? So we realize that when you move a set, okay, if you translate it by a certain scale factor or by a factor, wherever it gets to, the outer measure doesn't change. It is remained. Okay, so the outer measure is conserved even though it has been translated. So that's what we mean by measure being translation invariant. It doesn't matter the scale factor you are going to, or by what number you are going to translate the set or the interval with, you are always going to have the same outer measure. Okay, so to say that the measure is translation invariant is to say that when I have the outer measure, or this coming, which is a subset of real numbers, let me put it this way. If E is measurable, then we are saying that the outer measure of E plus Y is going to be equal to outer measure of E. Okay, so this is what we mean by translation invariance. Measure being translation invariant. So where Y also belongs to the set of real numbers as well. So now let's do the proof, which is very simple, which I think is the proof. So this proof here, the outer measure of E plus Y, we know that outer measure is what is it? Linear. It's a linear operator. So we have outer measure of E plus outer measure of Y. Okay, and we know that outer measure of E is an interval. We don't know its actual value. It could be 0 or not, so we still keep it as M star of E. But when we have this literal, from our literal understanding of outer measures, we say an outer measure of every single element is 0. Okay, so we just put that 0 here and we realize that the outer measure of E plus Y is giving you the outer measure of E. Okay, yes. So this is actually the explanation and the proof to the second lemma or a proposition. All right, so see you in the next video. In the next video, we are going to prove the third proposition over here, and in times to come, we are going to continue with the proofs and the explanations as well. All right, so see you in the next video.